In this review section, we're going to look at some basic principles of solving equations and inequalities. And so we're going to start with this equation here, solve for x. And we have parentheses. So the very first thing that we want to do is distribute that 4 and get rid of the parentheses. So we've got 4 times 1 gives us a positive 4. And then 4 times a negative 3x gives us a negative 12x is equal to 9 minus 7x. So as we look at the variable, we see that there are x's on both sides of the equation, and we want to get rid of one of the terms containing the x. So the coefficients over here are negative 12 and negative 7, and even though the magnitude of the negative 12 is greater, because it's a negative number, it's actually a smaller number, so I'm going to get rid of this term by adding 12x. And when I add 12x to both sides, what I'm going to see is the negative 7x and the positive 12x give me a positive coefficient on the x. So on the right hand side I have 9 minus, but positive 12 minus 7 gives me a positive 5x on the right. On the left, the 12x's cancel and I just have 4. And so solving for x, again I go after the variable, I undo the junk, I subtract off that added on 9, and I end up on the left hand side. Positive 4 minus 9 gives us a negative 5, and on the right hand side I have the 9's canceling, so positive 5x. And then the very last thing that we do to solve for x is to undo that multiplied 5 by dividing. And I'm just going to exchange the order in the equation, but that we get positive x is equal to, and then negative 5 divided by 5 gives us a negative 1. So when we're solving equations, there are 3 possible outcomes of those equations. And the first outcome is actually what we experienced over here, where we got a single solution that x was equal to negative 1. And so if I have another simple equation over here, 3x plus 1 is equal to 7, I would solve it subtracting the 1 from both sides. I would get that 3x is equal to 7 minus 1 gives us 6, and then I would isolate the x by dividing by 3 and end up with that x is equal to 2. And that is a single solution. It's a well-defined solution. It's what we're expecting. But there are some outcomes that are a little bit unexpected. So if we take a look at the second example, we have this equation that x plus 3 is equal to x. And you can have more complicated equations, but I think this will do for us. If we try to isolate the x, we see x's on 2 sides of the equation. And so as we had done before, we usually try to subtract off one of them to combine our x terms, so we would subtract off the x. But what you would see is that x minus x on the left is equal to 0, and then you still have plus 3. But on the right hand side, x minus x is also equal to 0, and so you end up with this contradiction that 3 is supposedly equal to 0, but that's impossible. And what that means is that there is no value of x which can possibly satisfy this equation, and therefore there is no solution. The third possible scenario is an equation that looks like this, which is a tautology. You have just that x is equal to x, and if you were to try to simplify it further, you could try to subtract off the variable terms to ostensibly get both of them on the same side, but what we would end up with is then something like 0 is equal to 0. And this is not x equals 0, it's 0 equals 0. And when is that true? Well, all the time. No matter what value of x you would choose, 0 will always be equal to 0. So an analogy that I sometimes like to make is that when you have the situation x plus 3 is equal to x, I have 2 kids. One is 3 years older than the other. At what age will their ages be equal? None of them. When my 6-year-old is 6, the 3-year-old is 3, and even though we would add years to those ages, for example 10 and 13, they will never be equal. However, when you have x is equal to x, that would be like a set of twins. At what ages are their ages equal? Well, all of them. At age 1, 1 is equal to 1, they're both 1. At age 10, they're both 10 years old. At age 100, they're both 100 years, and their ages are still always equal. And so what we would say in this situation is that we have infinitely many solutions. And one way that we will sometimes write this is just the set of x, such that, and in this case we're going to say that x is a real number because we are only dealing with one variable, and when we look at equations where we have more than one variable, we will define them in slightly different ways. But for our purposes, we can write it this way in set builder notation.